Hello children, hope you have grasped all the previous concept and revised well. So children, today we will be going to study the combination of resistors. So how can we combine resistors? What are the ways in which we can combine resistors in a circuit so that their effective resistance can be utilized for various purposes? So in that case, the first concept is resistance in series. So we may write it resistors in series. So what do you mean by series connection? So I'll draw it first. Resistors in series means they are connected one by one, end-to-end connection. So I'm going to draw the diagram of course you know this is the circuit symbol of a resistor. So here there are three resistors connected in series. So that is R1, the other resistor is R2 and the other resistor is R3. So children, why they are called in series? So listen, if we are connecting a voltage source here, voltage source can be a battery. So naturally if there is a battery like that, you can connect a battery also instead of writing V. So what happens is that naturally the current start flowing, right? So let I be the current in the circuit which is flowing through this. So what amount of I that is going through R1 will again the same I will pass through R2 and the same I will pass through R3. Listen, there is no branches over here. So how can we identify resistors in series? Two resistors are said to be in series when all the resistors carry the same current. So what is different for them then? So what is it? I is the same. R1, R2 and R3 are different. So the potential difference across this resistor R1 can be called V1, where V1 can be written as I into R1 from Ohm's law. We know that V is equal to IR. So I is the same, R1 is different, so V should be different. So the part of the voltage that we apply goes in R1. Then what is it? Next is the voltage across R2 is written as V2, where we can write that V2 is equal to IR2. And R3, what is it? V3. So what is it? It is V3 is equal to IR3. So this is the concept of resistors in series. When the current is not getting divided among these resistors or the same current is passing through these resistors, we can say that the resistors are in series. Then what is different in these resistors? The potential difference, and the potential difference across each resistors, not the point, it is proportional to the resistance. If R2 is greater than R1 and R3, R2 will be the space where the more potential is dropped. You have to understand it. Greater the resistance, greater the potential drop across the resistors. So, what is V divided into in this? V can be written, now we are going to derive what is the effective resistance of these three resistors. So V can be written as V is divided across R1, R2 and R3, that V1 plus V2 plus V3. So what is V1? It is IR1. And what is V2? It is IR2. And what is V3? It is IR3. So that is the total voltage. Okay. So now we are going to derive an equivalent resistance. What do you mean by equivalent resistance in a circuit? Suppose we are replacing this R1, R2 and R3 with another resistor which can do the work or which is equivalent to all these resistors. So shall I draw an equivalent diagram here, or you can draw it at the other side, where the equivalent diagram can be shown as a total effective resistance, what I call as RS, is connected across the voltage source V. So what happens is that the current is driving. So What is V here? It is I into Rs. What is Rs? Rs is the equivalent of R1, R2 and R3. What is done by R1, R2 and R3 is now done together by Rs. So, from this diagram, we can replace this V because same V is getting applied in this. This is the circuit diagram, this is its equivalent diagram. So, can I write it as this V as I into Rs? So, of course, we want to find the resistance in series. So, what is resistance in series? Resistance in series will be, we cut all the i's from this term where we get, it is the sum total of all the resistors connected in series. So what is the effective resistance of three resistors connected in series? It is R1 plus R2 plus R3. So now let us list what all are the characteristics of resistors in series. So please list it with me. So what is it? The first point is the current in all resistors remains same. Current in all resistors are same, right? The second one, the potential difference or the potential drop. You have to write the notes if you need it. Potential drop across the resistors are different. The potential drop across the resistors are different. These are the important notes regarding series connection. Resistors are different, and these potential drop or the voltage across the resistors, potential drop or the voltage across the resistors is proportional to the resistance. This is the point that you have to note. Current in all resistors are the same. Potential drop across the resistors are different. So, potential drop or voltage is proportional to R. Now, going to the third point, we have noted that resistor in series, the equivalent resistor in series is R1 plus R2 plus R3. So let us go for an example. Listen children, suppose there are 1 ohm, 2 ohm and 3 ohm connected in series. What is the effective resistance? It is 2, 3 plus 2, 5 plus 1, 6 ohm. Look at this effective resistance. This effective resistance is greater than the greatest of the resistance used, isn't it? Listen children, which is the greatest of the resistance used? It is 3 ohm. And what answer we will get? It must be, when you do a numerical, it must be greater than the greatest of the resistances used. So, as Rs is equal to R1 plus R2 plus R3, the effective resistance, please list it, the effective resistance is greater than the greatest of resistances. Greatest of resistances. Now, there is a small note for you, additional, it is not given in your textbook, where we are using identical resistors. Suppose we are using n identical resistors. Suppose we are using n identical resistors. So what is it? Let us consider it with the 2 resistors. Suppose we are using 2 resistors in series. So what is the effective resistance? Both resistors are the same. So what is it? It will become R1 plus R2. So we know that here R1, R2, etc. are R only because they are the same. So R plus R. So what is the effective resistance? It will become 2R, right? Suppose there are 3 identical resistors used. So what will be the resistance? Rs, it is R plus R plus R. So what is it? 3R. So can you generalize it? Suppose there are n identical resistors used. The effective resistance will be n into the value of a single resistor. You may please note, in series, if there are n identical resistors, the value of the effective resistance will be n times the value of one resistor. So if there are 100 resistors of resistance R, what will be the effective resistance? It will be 100 into R, that is 100 R. Hope that you have understood. We will come with more numericals on this session. Thank you.